Good day everyone. This is now chapter 2 on the topic operating system structure. This time we will continue with the discussion. Sorry. As this is rooted from the basic concepts of chapter 1. So the subtopics na nakikita nyo ngayon, it is very much related to the topics of chapter 1, in which na marami po kayo nakikita ngayon na mga subtopics na i-discuss na rin po natin sa chapter 1. So in details, makikita po natin yung kanyang relevance on the structure of operating systems. Again, it is always an advantage to listen to the discussion of chapter 1 before proceeding on the topic chapter 2. As to our goals, the goal of this chapter is to describe the services of the operating systems extended to users, processes, what are the ways of structuring operating systems, and how operating systems are installed, customized, and initialized. Also, we will check on the different services of the operating systems on various views. Okay, so we have the operating systems services. Okay, nasabi na rin po natin itong mga services. Ano-ano po yung mga services, just for the review. The operating system provides environment for execution of the program. Para ma-execute mo yung program, kailangan meron kang operating systems. Execution man yun sa ating source code, sa ating programming languages, execution man from the application programs, then there should be an operating system sa lahat ng mga commands po natin. The operating systems provide services to programs and users that use those programs, application programs, even operating systems, the virtual machines, your games, kasama po doon sa users program. We identify common classes of services for all operating systems. Now, there are set of interfaces. Okay, meron po tayong users interfaces so that we can use the operating system. Para magamit si operating system, meron po tayo tinatawag na command line interpreter. And the other one is graphics user interface or graphical user interface. Also, merong batch. Okay, I'll show you some interfaces para maging transparent po yung execution. Like, if I have the CLI, so I can invoke it from here using CMD. So, I will run as administrator so that I can have the privilege, more privilege compared to a simple user. So this is the command line interpreter. It's not that user friendly because you have to memorize some code. So just a simple illustration, say for example you have cd backslash. Cd backslash means change directory, and that it will go to the root. So if I'm going to check the contents, dir, okay, so these are the contents of my C colon. So pag nakita po natin etong dir, yan, ibig sabihin there is that subfolder. Okay? There is that subfolder named banks, named Casper. So, yun yung kanyang subfolder. Now, if we are going to check from here, dito po halimbawa sa drive C. Okay? Ito po si drive C. So, it's consistent. Kung ano po yung nakalagay doon, sa mga files kanina na naka-display, these are also the folders available. Okay, so if we are to check between the interfaces, syempre, mas madaling gamitin si GUI. But, of course, may advantage tsaka disadvantage yung paggamit po nilang dalawa. Okay, so one of this, pag kinlik mo halimbawa si GUI, you are seeing icons. It's more presentable. And, of course, the details are shown here. Kaya tinawag siyang graphical user interface because meron po tayong mga icons available. We can integrate some enhancement on how it looks. Now, si CLI naman, it's just a simple command line interpreter where you have to identify, kailangan memorize mo po yung mga codes dito. So, if you wanted to copy, dito ka, right click ka lang, copy, paste. So, ganun kadali. Dito, you need to memorize. So, you have to say, copy, ano po yung pangalan ng file, lalagay mo po siya, space, and the destination, kung saan mo ilalagay. So, there are several DOS commands that you can work with your command line interpreter. Even the batch systems are integrated in your command line interpreter. So, dito, going back to our slides, we say that the user's interface may be through a CLI. Para magamit mo si operating system, pumunta ka sa command line interpreter, you can manipulate. O di kaya on the graphical user interface, which we showed a while ago. I showed a while ago the Windows Explorer. And sa batch, kasi maraming code to na ibig sabihin, lalagay mo po yung kanyang pagkasunod-sunod. So, maaaring ipoprogram po siya sa shell. Just to describe the batch systems, you have a series of codes, sequential, 1, 2, 3, 4, 5, and then those will be the conditions as you execute the command. Hindi siya katulad ng command line na pa isa-isa. So, if it is by batch, it will give you the conditions that you set on the batch code. Okay? So, that is for the user interface. There is that program execution. Isa po sa napakagandang services ni operating system is that it can execute your program. It's useless na meron kang code, marami kang alam, and that you are not seeing the result. So, by program execution, the system must be able to load the data program into the memory. So, nag-type ka sa keyboard, you have executed a source code, kailangan yung code na yon, yung operations na yon, it has to be passed to the memory. So, once it is on the memory, it will be manipulated and the results will be displayed on your display device, output devices. Pero what makes it possible for you to bring those instructions to memory is your operating system. What makes it possible from memory to your display devices, between those display devices and that memory, there should be an operating system to transform inputs into the desired results. Now, with the results, it is not at all times normal, or it is not at all times successful. Maaaring, as it brings about result, successful siya o hindi. Kaya, meron tayong input-output operations. Also, some processes might be normal, some processes might be abnormal, halted. So, a running program may require input, output, which may involve a file or an input-output device. Okay, still continuation on operating systems services. So, we said that the operating system is a resource allocator. Again, the operating system is a resource allocator. So, it's not only intended for the hardware. When it comes to resource allocation, it might be extended to softwares, to systems. By resource allocation, there are considerations of users logged into the system, like in a clustered system or distributed systems. Resources must be allocated to this user. As I was saying, on resource allocation, in an instance where there are multiple users that are logged onto the system, the operating systems must allocate the resources onto the different users. So some resources have a special allocation code. These are the internal considerations. There are others with the general request, or probably there is a release code. Next, on accounting services. By counting, the operating system can keep track of which users use how many and which resources. So there could be valuable information that would be contributed to the reconfiguration of the systems, the computing services. So by accounting, it means to say that the activities associated to files, activities related to operations are stored by your operating systems. If it's not stored, it is properly accounted. Next, on protection and security. Protection and security considers concurrent processes, especially in a network environment, that these concurrent processes should not interfere with other processes. It could be users that are logged into the different systems. So then we have to make sure that there are considerations of authentications, there are considerations of access rights. The security of the system from other outsiders requires authentication, so it extends to defend the system. Devices should be considered on several attempts, like yung login sa mga devices, ilang attempts ang dapat natin i-consider to protect the system. Next, on the figure. Tingnan po ninyo na mabuti yung figure natin. Kanina we describe the user's interfaces as to be GUI batch command line. Ito yung ginagamit natin for the triggers. Now, the moment that we have the triggers coming from programs, machines, or probably users, dito na po gagana si systems calls. Kasi yung instruction manggagaling po sa user's interface. Si operating system will now act through these systems calls. So, pag meron na pong gumagana na OS, the services will be made available. So, we discuss the services as to the execution of the program, input-output operations, the file systems, communications, resource allocation, accounting, even the security and protection and error detection. Ito yung ini-emphasize po natin na services ng OS. So, this is the umbrella operation of the operating systems. So, the operating systems will now communicate the user's input from the hardware. So, this is now the concept on the definition of the operating systems. It is an intermediary between the users of the systems and the computer hardware. The OS is an intermediary between the users of the systems and the computer hardware. So, it is very clear in this illustration. Now, si CLI. Kanina we demonstrated the CLI and the GUI. People, ang slides na to, it's intended for your section. I have shown some contents of my files. Well, I trust you with that. I am very honest na yun po yung execution ng GUI. So, let it be for the purposes of illustration of the user's interfaces on the command line interpreter. So, as you observe kanina, the command line interpreter, you have to really code it one at a time. Hindi siya memory, hindi siya basta-basta na lang i-click. Kailangan you have to memorize the syntax as you use the CLI. The main function of the command interpreter is to get and execute the next user-specified command. Kaya nung nag-e-enter ako, di pa bumabalik po siya sa command prompt. And then there is that cursor that awaits for the next instruction. Many of the commands are used to manipulate. Pwedeng create, copy, print, execute. So, kung ano nagagawa ni Windows Explorer, kaya din pong gawin doon sa command line interpreter. Of course, there are some considerations on the versions, on the limitations as well. Kasi kung ginagamit mo halimbawa si version Windows 7.0, then you have to check on the system's capabilities. The general ways to implement commands in CLI is to interpret. Kailangan i-interpret ni OS yung mga code necessary for executions. The commands are implemented through the system's programs. Okay, how about the GUI? Ano nga po ibig sabihin ng GUI? It is the graphical user interface. Nakikita nyo may mga icons, nakikita nyo na may mga pa-color. So, there's no need to enter the commands on GUI. You make use of your mouse click, double click, There are windows, there are menu systems characterized by your desktop. So, the mouse is used to move a pointer to the position of an icon that represents a file. So, there are program folders, and by clicking on the program, then it is invoked. Okay. Next, the system calls. Di-define po natin uli ha, kasi last time we made mention of the system calls in chapter 1. So just a refresher, system calls provide an interface to the services made available by an operating system. So nag-click kayo doon sa GUI, CLI, sa batch file. So it will be now passed to the operating systems. Gagana na po yung kanyang mga services once you have the system call. So their application developers design to execute this interpretation ng system calls. The API, for example, defines a set of functions that are available to an application program. It includes the parameters passed to functions and then return the values to the programmer that can accept it. So, ibig sabihin, ito yung mga transformations. Standard API. So, on the figure, tingnan nyo po yung mga codes ni API. So, what is the implication of the examples of standard API? Let me just give you an input. An application program interface is a code that allows two separate programs to communicate with each other. An API defines the correct way for a developer to request services from an operating systems or other applications programs and expose data within different contexts and across multiple channels. Therefore, the program becomes portable and no need for you to worry about the internal details. Si API na po ang bahala doon. Okay? Next is on the concept of system call implementation. So, the system call implementation, it occurs on different ways in different computers. There are three general methods po in the use of passing of parameters. That is through the registers, via registers, using a block or table in memory, and the address is passed as a parameter in a register. So the use of a stack, remember the data structure in stack, there's the front and the rear, where there is possible for the execution of the parameters. You push the parameter on the stack and then pop off the moment that the operation is executed. So the block of stack methods do not, however, limit the number of length of parameters being passed. Okay, so tingnan nyo po yung figure na to. So, ito po tayo, user application. We have here the interfaces, yung ginagamit po natin ng mga graphical user interface, the CLI. So, it is being initialized by the program. So, the operating system and the program works hand in hand in the opening of the file of triggers, then the operating system comes in. So, if it is on the user mode, galing po siya sa triggers ninyo using the interfaces. It's user 1. Okay, it's user mode, and then pagpasok na po ng operating system, it is now on the kernel mode, and the subroutines of the operations initiated on your interfaces. This time we have system call parameter passing. Before discussing the processes, let's identify po muna what is system parameters. So, these are constant values that define the directories which the data integration service stores, such as the cache files, reject files, source files, target files, could be the log files, and temporary files. The parameters are placed or pushed onto the stack. So, that's by the program. And as you know, pag sinabi nating stack, ito yung you push. There are pop operations. So, parameters are subjected to this. The block and stack methods do not limit the number of length of parameters being passed. So, we have here the figure. The system call parameters have three general methods. Ito yung nakikita ninyo sa figure. So, the general methods exist for passing parameters to the OS. Una, parameters can be passed in registers. Parameters can be passed in registers. When there are more parameters than registers, then parameters can be stored in a block and a block address. It can be passed as a parameter to a register as well. The types of system calls. So, there are 6 major categories na dapat nating tandaan. Each of this with the following types. Ano po yon? You have, unahin na po natin si process control. And later, we'll discuss the rest. This 6 major types of system calls. Una, si process control. So, a program needs to be able to end execution. So, once it started, it has to end its execution. Otherwise, maghahang siya kung hindi na siya nag-i-end. Now, the execution could be concluded normally by the operating system. That's the expectation. However, it is not normal at all times. Maaring there are abnormal termination where you need to abort. You have to ignore. So, when abort, the memory, there is a memory dump which is written to the disk for use with the debugger program. That's to find the program. The operating system must transfer control to the next invoking command interpreter. So the command interpreter then reads the next command. Okay, so the normal way. In interactive systems, the command interpreter simply continues with the next command. So sa GUI naman, system, there is that pop-up window that will request actions from the users. So, may mga instruction tayo through the dialog box. O di kaya there are window box for error messages. Sa batch system naman, the command interpreter terminates the whole job. So, kung isa dyan, nagkaroon ng problem kasi when you say batch, ang dami nila, ang daming sequence of jobs. So, once merong isang may problem, that would terminate the whole job and continues with the next batch. So, the batch systems make use of control card systems. So, there are embedded systems as well on batch systems. Kaya tuloy-tuloy na gumagana yung mga machines because there are already instructions held on a batch. So, if an error occur in execution, an error level is assigned. The error level can be used by the command interpreter or other program to determine the next action. So, we were able to consider the different interfaces on process control. Next po tayo. We have another type which is about file management. Now, ito, si file management, very common to everyone. Kasi when you are to create files like you have a video, so may mga extension names, you have the PowerPoint slides, Excel file, you have the database file. So, the file management is for the creation, for the deletion. Generally, there are 5 access rights to a file. So, you have the CRUD, the CRUD, create, read, update, and delete. Okay, so, what are the considerations of file management in operating systems, or how operating systems it is integrated on file management? There are system calls that deals with the files. So, a file needs to be created, then opened for use. So, nagdo-double click kayo, open nyo yung program, you have to create, and then you can open this for use. After the file was read from or written to the file, it needs to be closed to indicate that it is no longer in use. So, we need to be able to read and write in the attributes of such file. Some operating system, we can move and copy files, can be able to manipulate this in different subdirectories. So, pwede lang ililipat-lipat. Okay, so those are the things for us to consider on file management. It's different operations. Next, we have the device management. So, device, we consider this as a resource, device management. So, these are resources that are needed to process. It's needed by a process to execute. Okay, so what are the examples of devices or resources that we refer to here? We have the main memory, you have the disk drives, you have the operations access to files. So if resources are available, they can be granted, and that it can control and it can return as well to users processes. So there could be trigger coming from different interfaces through a system call. The operating systems will respond and then pass this operations to the hardware, from the hardware going back again to the operating systems bringing this back to the output through an interface. In a multi-user environment devices, okay, so may mga network environment, it should be locked by a particular user to prevent devices contention and deadlocks. Some are physical devices and others are abstract or virtual devices. The information maintenance. Okay, so by information maintenance, we would like to consider the very origin, which is the system call. So system calls that is used to transfer information between user and program of operating systems. Like this information could be time and date, the version number, the number of concurrent users, free memory or disk space. We consider also the debugging information in an information maintenance. The debugging information needed for the program debugging is also provided in information maintenance. Okay. Communications. So, by communications, we would like to transmit and that we consider recipients and senders. So there are triggers and activities that involves in the communications process would be create, delete, connect, send, receive. So it could be from client to server, or it could be a response from server to client. There are considerations of shared memory in order to create and gain access to memory regions. So ang pinaka-focus natin dito is the transmission. So we transfer, and that the operating system must know the status of the information that is attached and detached on different devices. Protection. So, protection provides a mechanism for controlling access to the resources provided by the system. So, this is usually implemented in internet networks protection. It's very important to consider a multi-user environment. So, some system calls that is considered in protection would be get file security status, set file security status, allow user, deny user, set file security group. Okay, so that would identify restrictions of programs and users. Now, we have here the types of activity. So, we discussed the different types of systems call as to process control, file management, device manipulation, information maintenance, communication, and protection. So, ito yung different types of systems calls executed by the operating system. Now, there are vendors like Windows and Unix. So, these are the processes associated, the processes that they use in this types of systems call. So, when you are creating program, gagawa kayo ng program sa Windows, so this could be integrated in the syntax as you process. These are the related. Okay, so the figure here will give you an idea on what are the internalities, the subroutines that is considered on the different types of systems calls. This is in relation to Windows and Unix systems. The system programs. System programs are also known as systems utility or system utilities. It provides a convenient environment for program development and execution. So it is divided into the following categories. Ito. So you have the file management, you have the status information, you have the file modification. Saan yung file modification? Let me check. So, isa-isahin po natin sila. First, the file management. So, si file management, these are the operations for the creation, deletion, copy, rename, print, dump, list. We manipulate files and directories in file management. Those are the considerations. So, the status information, we consider some programs, and that with the programs, there are attributes of date, time, disk space, number of users, and usually, nakikita po natin ito sa properties. Now, there is also file modification. Kahit hindi po nakalagay, we have to consider file modification. And there are several text editors that may be available to create and modify the content of files stored on a disk. So, sa file management, ito yung available. Once it is existing, once it is created, you can do updates. So, yung pag nag-update po tayo, ito na po papasok si file modification. It's related also to file management. Okay, we have now operating systems design and implementation. Paano dinidesign at ini-implement si operating systems? Now, let's classify this according to the user goals and system goals. So, user goals tayo yon. So, accordingly, sa user goals, ang gusto niya sa operating system should be convenient, madaling gamitin, easy to learn, reliable, safe, and fast. So, ganun tayo tumingin sa operating system. Now, si system naman, si operating system, ano yung gusto niya? Ano yung goal niya? So, operating system should be easy to design, should be easy to implement and maintain, as well as flexible, reliable, error-free, and efficient. So, it's more on internality. Sa user naman, usually, yung paano niya gamitin ito. Madali niyang gamitin. So, there are important principles to separate. And what are these principles? The policy and the mechanism. So, pag sinabi nating policy, what will be done. What will be done. So, these are the conditions na dapat sundin sa operating systems. There are rules, there are protocols. Those are policy. Also, we have mechanism. Mechanism means how to do it. So, there are set of processes. So, if there is the policy of authentication, you wanted to identify only legit users of the systems, there should be policy like you have to consider the authentication sa password, you have the considerations of PIN, and mechanism, how are you going to implement this? So, pag nagkamali, pag tama, paano you validate? Those are the steps. Those are the processes. The mechanism. Policy would mean rules. Could be standards. Okay? So, mechanisms determine how to do something. Policies, how to decide what will be done. So, the separation of policy from mechanism is a very important principle because it allows maximum flexibility if policy decisions are to be changed afterwards. Maingay. Sorry. So, going further on the implementation, so there are problems. There are problems faced in designing and implementation of the operating system. The design and implementation of operating system is not at always solvable. So, but there are approaches that have been proven successful. Internal structures of different operating systems can vary widely, starting by defining the goals and specifications, and that is of course affected by the choice of hardware and the type of system. So, there are dependencies. So, sa paggawa ng pag-i-implement ng operating systems, siya po ay pinoprogram din. Hindi siya basta na lang sumulpot ng kusa na naging operating system na siya kaagad. So, operating system ay pinoprogram din. As you all know, kanina sa systems calls, di po ba we have set of methods. So, there are steps to be considered. There are implementation which requires programming languages to implement an operating system. Saya natin sa ingay na to. Okay, so there the operating system structure. What are the consideration? Maaring sa structure, simple structure, layered approach. So, let's try to check on the different structures of the OS. So, unahin natin si layered approach. This is somehow very common, si layered approach. So, the operating system is broken into several layers. So, in this case, we have layer 1, layer 2. So, it's a typical layer. It has routines that can be invoked by higher routines. While the advantage is there is modularity in layer 0. Iba to. Another modularity on layer 1. A layer doesn't need to know how lower level layer operations are implemented, only what they do. So, doon lang siya nakafocus sa kanyang layer if there are operations. So, that is for the layered approach. Now, ano yung application ng layered approach? Bago po tayo mag-microkernel, explain ko po muna yung example ng mga layered approach. Halimbawa, sa virtual machine. Di po ba nakakapakita natin sa chapter 1 sa virtual machine? A virtual machine takes the layered approach to its logical conclusion. So, it treats the hardware and the operating system's kernel as though they were all hardware. A virtual machine provides an interface identical to the underlying bare machine. Sa virtual machine, meron po tayong tinatawag na bare hardware. So, yung nagpo-produce naman siya ng replicate of the same hardware. It treats hardware and the operating system kernel as though they were all hardware. Ganun po yung concept ni virtual machine. So, the operating system creates the illusion of multiple processes, each executing on its own processor with its own virtual memory. So the resources of the physical computer are stored to create the virtual machines. There is CPU scheduling that can create the appearance that the users have their own processor. Spooling and file system can be provided on virtual card readers and virtual line printers. Okay, after the layered approach, which we illustrated through the virtual machine, we'll have now the microkernel system. So, just to give you an input on the approaches, microkernel approach, all non-essential components are removed from the kernel and are implemented at system and user programs. So, meron siyang mga filters na ginagawa. So, the smaller kernel provides minimal processes and memory management. Kaya, kung nakikita ninyo yung ating RAM, it's only intended for the operations. Operations lang siya, yung mga processes. That's intended for the cache, for the register, for the RAM. So, pag halimbawa, magsisave na siya malalaking processes, kailangan niya na si file management, ilalagay niya na yon sa secondary storage device. If it is a permanent storage, na yung file na yon na to reside, yung process na yun has to reside in a bigger memory. So, nililipat niya na. Hindi niya na ilalagay doon sa microkernel system structure. So, the advantages is that there is ease of extending the operating system services. The operating system is easier to port from one hardware, and thus it is the design is considered towards another. It is more reliable. If there are failed user service, it won't affect the operation. Main functions of the kernel. The main functions of the kernel is to provide a communication facility between the client program and the various services. Okay, so let's check on the microkernel structure. Tingnan nyo mabuti yung figure na yan. Now, if the client's program, user mode if the client program wants to access a file, it must interact with a file server. It has to interact with a file server indirectly through the microkernel. So, it's real-time OS that is based upon the microkernel design. Windows NT uses a hybrid structure. We'll have the modules. Okay, let's proceed to modules. Most modern operating systems implement kernel modules. Yung meron siyang clusters. It uses object-oriented approach and each core component is separate. Each talks to the others over known interfaces. It is loadable as needed with the kernel. So, over similar layers, meron din siyang mas flexible strategy si module. Okay, let's check. Tingnan niyo po yung figure ni module. So, this is a system for Solaris kernel. Ang kanyang approach is modular. So, by modular, it uses object-oriented approach. Okay? Ano yung pag sinabi nating object-oriented approach? Don't forget to consider the principles. Merong abstraction, merong polymorphism, merong inheritance, meron pong encapsulation. So, each core component is separate. However, each talks to the others over known interfaces, and each is loadable as needed with the kernel. Okay. Next, we have the hybrid systems. Okay. So, kanina, may layered approach. We have the modules. Now, if there are several combinations of these approaches, we have the hybrid approach. The hybrid operating system may allow one operating system to fulfill one set of requirements and the other operating systems to fulfill the rest. So, maaari may consider ng cluster, consideration ng cluster the modular, and then maaaring layered. For example, one of the operating systems may provide user interface applications for monitoring, while the other operating system may be a high-performance operating system that does not provide the same services as the first operating system. Well, one of the ways is to install the operating systems through a bootstrap. Okay, naalala nyo yung bootstrap, yung pag-initial start. So, the first operating system, the bootstrap is the first operating system with all the system's resources. And then, the other half of the system resources are allocated to the first operating systems, and the second operating systems is bootstraps with the remaining system's resources for the next operations. We have the Mac OS structure. Ito naman yung structure ni Mac. The Mac OS is a graphical operating systems developed by Apple Incorporated. So, the 10th version of the Mac OS is the Mac OS X, which was launched in 2001. So, the structure of the Mac OS includes multiple layers. The base layer is kernel extension system. Kernel extension system. The next layer is the kernel environment. Then is the application layer, which has 4 components. Namely, you have QuickTime, you have HOA, BSD, and Java. So, the top layer is Aqua, which is the user interface. So, ito naman po si Mac OS X. Next, syempre, kilala nyo si Android dahil marami po sa atin gumagamit ng smartphones. Ang operating system is the Android. The Android software stack generally consists of a Linux kernel. So, sa Linux naman po nakabase and collection of C and C++ libraries that is exposed through an application framework that provides services and management of the applications and runtime. So, si Linux kernel is created from Android. Yan po yung foundation ni Android. Android was created on the open source kernel of Linux. So, one main reason for choosing this kernel was that it provides core features on which to develop the Android operating systems. This is the architecture for Android. Okay? So, there are libraries, there are considerations of runtime. The operating system debugging. So, kahit hindi sa OS, kahit sa programming languages, naririnig po natin si debugging. Debugging is the process of finding the problems in the computer system and solving them, and that we have the considerations of the log files. So, si operating system has also debugging, that is finding and fixing the errors. Kung hindi niya makita yung error, hindi niya ma-fix, maaring ma-deadlock, maaring maghang si operating system. So, yung isa sa pinaka magandang feature na nai-enjoy po natin is the debugging feature of the operating system. Kasi it is an assurance that we can still continue working with our hardware and software. The performance tuning. Okay, anong ibig sabihin yung tuning? Yung tinotono, performance tuning. So, ano-ano po yung consideration sa performance tuning? Ito, di ba, familiar tool for task manager. So, when you are to check on what is currently running on your system, yung kanyang mga properties ng pag-run, tinitingnan po natin sa performance tuning sa kanyang Windows task bar. Kasi nandun po makikita yung status. Performance tuning is the improvement of systems performance. So, some implementation of performance tuning are the implementation of the D3. So, sa performance tuning, ito po yung mga considerations of actions and operations. The operating system generation. Ano-ano na yung mga considerations sa generation ni OS. Operating systems are designed to run on any of a class machine. So, the systems must be configured for each specific computer site. So, may sysgen. Narinig niyo yung sysgen, yung pag nagko-code. It is configuring a system for each specific computer task. So, hindi ibig sabihin na si operating systems generation na dinidescribe natin is a factor of time, like history. So, ito po ay functionalities. The sysgen program must take into consideration the file and operator. What CPU will be used? How will boot disk be formatted? How much memory is available? What devices are available? What operating systems options are desired? So, it's the system administrator that can use all the activities and can be subjected to modify a copy of the source code of the operating system. So, there are systems description that can cause the creation of tables and the selection of modules from a pre-compiled library. So, these modules are linked together to form the generated OS. Okay. Next, we have the system boot. Lagi nating pinag-uusapan sa system boot. Yung pag-start ng computer, turn on the computer. Pag turn on yun ng computer, wala po muna kayong makikitang ibang functionalities maliban sa operations, the operating system. So, walang gumagana muna na hardware. Initialize muna sa boot. Yung mga software, the application programs. So, kailangan, bago po siya ma-load, yung mga browser na yan, it will first be initialized by the operating system through a system boot. After an operating system is generated by the bootstrap program, it locates the kernel and loads it into memory and starts its execution. So, booting is the starting of a computer by loading the kernel. Yun po yung pinaka-importante nating tandaan when it comes to system boot. There is that bootstrap program that makes this activity possible. So, there are codes stored in read-only memory that is able to locate the kernel, load it into memory, and starts its execution. The operating system must be made available to hardware so hardware can start its operation. So, there is that small piece of code loaded on the bootstrap. It locates the kernel, loads it into memory, and starts its execution. So, sometimes there are two-step process where boot block at fixed location loads bootstrap loader. So, when power is initialized on the system, execution starts at the fixed memory location, which is your ROM, a read-only memory. So, it is used to hold the initial boot code. The operating system can be implemented with the help of various structures. The structure of the operating systems depends mainly on how the various common components of the operating systems are interconnected and integrated to the kernel. So, the kernel, para ma-emphasize po natin, the other term actually of operating system is the kernel. But in specific, the kernel is a computer program at the core of computers' operating systems with complete control over. Again, the kernel is a computer program at the core of a computer's operating systems with complete control over and everything in the system. So a structure of an operating system determines how it has been designed and how it functions. So in this chapter, we discuss several ways on the design, components, and structure of operating systems, as we also describe this in the different operating systems designed by vendors. Like you have Unix, you have Android, you have Windows. Okay, so this ends chapter 2, people. Hope that you have now the understanding of the operating system structures, okay, its properties, the consideration on how it is being organized. Please do prepare your questions na lang po on our synchronous meeting. I'm sorry for the background noise for now, kasi marami po talagang mga activities dyan yung aking mga kapitbahay. Pasensya na po. The asynchronous activity will be uploaded later. So, along with the uploads of the video, isasama ko po yung pag-upload ng ating asynchronous activity. So, this lesson of chapter 2 is equivalent to the synchronous meeting for this week. Okay? At least dire-diretso po ito. And the next week, we'll have the validation of chapter 1 and chapter 2. So, please be ready for the question and answer dito po sa chapter 1 and chapter 2. There will be a graded recitation for this. Also, please prepare for a quiz for chapter 1 and chapter 2. Before the quiz, uunahin po muna natin yung ating validation, and then even before the validation, I will still accept po muna your question and answer, then proceed on the oral graded recitation and the evaluation through quiz merging chapter 1 and chapter 2. So for now, focus po muna kayo sa review of the slides and then answer the asynchronous activity. So I'll see you next week, people. Keep safe, everyone. Have a good day.